Hello everyone, I am Anubhav Majumdar and I am going to present to you today my product AVAC, a new object detection and identification tool for driving under foggy conditions. As you all know, under foggy conditions, the visibility is very less, and this increases our chances of making mistakes or accidents during foggy conditions. So, we all don't want this to happen time and again. So, I have come up with a solution. The name of my solution is AVAC. So together we can bridge the gap in the technology access and opportunity together. So I'll be putting up a link for the Google Drive presentation of this presentation only. Okay. So this is a brief introduction about me. I'm a BTech in Electronics and Telecommunications student. I'm a third year student. Here's my LinkedIn, my email ID. This is the hackathon I participated in this hackathon last time. So this was my hackathon project. It was on diabetic foot. So these are the projects I have done. You can go through this details. These are the hackathons where I participated. This is the content. Let's start with the problem statement now. My problem statement is to develop a cost-effective sensing mechanism for object detection and identification under foggy conditions. So the problem in foggy situation visibility becomes a very major issue. And you can see foggy roads kill so many people on a daily basis. In 2014, 16 people were killed daily in such accidents. According to Times of India, fog-related fatalities are only increasing day by day. They are not decreasing. So it's the high time that we put focus on these technologies. These are actually life-saving technologies. So the sensor with a combination of the following will work most accurately. The first one is solar and radio waves. It should be integrated with an AI-guided road navigation systems and audio-based detection technologies in curbs and side sonar for detecting obstacles at the side of the road. Uh, so, so coming with our first product, it consists of sonar and radio-based 3D mapping technologies. So as you can see, as the car is going through a foggy road, the visibility is very less and chances of accidents are very high. So in this case, we are using sonar sound navigation systems for detecting the objects, the cars, or any other potholes, or the condition of the road, even so that the we could put up a much larger perspective to our drivers, so that the chances of making mistake or the chances of accident get reduced considerably. So this technology is already in use in ocean depth and ocean floor 3D imaging. So I thought of why not extend this technology into this field also, if it's very promising. So the sonar and the radio-based 3D imaging of portholes and the conditions of road. So this picture you can see it's of a canal. A person has tried to map a canal using sonar technology, and you can see it's very much accurate. Okay. So this is the principle of sonar operation. Sonar operates on the principle of sound reflection called Doppler effect. You can go through the sonar techniques. Why sonar as a porthole or road condition? So why sonar? So basically 3D construction of an underwater structure, if it's possible, then it's also possible that we can penetrate here, the waves can penetrate here and then they get reflected back and we get a 3D image, a 3D reconstruction image of the road also. So that's the basic logic behind this. So a car on a foggy and a rainy day, the position of sonar and the radio transmitters for 3D reconstruction of the road and its condition has been shown here. Here the sonar sensors under the body. The white dots represent the sonar, radio transmitters and the receivers here, here, here. Okay. So it's the process. I have put up a flowchart for this using sonar and radio technologies. So these are the features that the sonar technology, with the solar technology, we can. So using sonar and the radio technologies, what are the features that we can offer? We can offer porthole detection and auto diversion. It basically means if the system detects a porthole, then it would auto divert the road, taking into consideration other cars ahead and behind. So the forward car mapping and the AI guided reconstruction, as you can see in the picture, if it actually maps the entire road and the road traffic, which we can't see due to foggy conditions. Side sonar, if a car is passing by, then the sonar would also detect it. If a car is at the back, then the sonar will also detect it. So sonar for measuring the speed of the car coming in the opposite direction. Car is coming in the opposite direction and the sonar will also give you an alert. It's using the simple principle of Doppler effect of the sound waves. So the requirements of the product are sonar transmitter, sonar receiver, AI tool for sonar reconstruction, machine learning for object and obstacle identification, the user interface, and the radio transmitter and the receiver. All have been listed down here. So there are certain problems of using sonar. We can't use sonar in each and every case with 100% accuracy. So here, as you can see, the car is going through a very steep turn and you can't see on the other side of the road. In foggy condition, this becomes a very difficult situation for drivers also. So using sonar at sharp turns can produce error due to interference or false reflection as they have long wavelengths. It's due to the effect of interference. So don't worry, we also have a solution for that. The concept, the sound sensing, if a car is traveling on the other side of the road, then you would have certain ear disturbances created due to the motion of the car. Then if we are using a highly sensitive microphone, then such disturbances we can actually detect, and with the help of AI we can also decode their information. We could also give an alert like if a car is coming from that end or not. There's a beautiful picture representation of the thing. You can go through it. And this is the overall schematics. These are the requirements of the process of action. We have the noise capture, sound amplification, sound identification with AI, and alerting the user that a car may be coming in the opposite direction. So to this product, to enhance its accuracy, we could also use GPS technology to get real-time feed to reconfirm the presence of the car. So this is our product. This is the summary. So giving a competitive analysis, I have innovated the ideas myself and have attached proof of concept also. I've used existing hardware concepts, bunched with class 11 physics concepts to advanced AI tools. I hope you'd like it. So why the customers will choose our product? It can achieve high accuracy rate. It's cost efficient and it will save your life as well as the others on the street. So you are not saving 1 or 2 lives, you are saving thousands of lives. So the size of our market, total number of cars in India, number of cars in foggy areas, this is a rough estimate. I have only excluded some parts of South India where fog conditions are really present. So number of car accidents and fog, it's staggering number. So this is the budget for sonar. We have cost approx around 40K for the AI tool for the highly sensitive microphone, the cost of the development. All I have listed down. So this is an approximate budget. We can also reduce the budget if we work hard and work with a team. So this is basically the timeline, the prototype testing looking for flaws, deployment in a car, trial run, and troubleshooting, final safety testings and launch. So with the VAC technologies, make your drive safer in even the most foggy conditions. This is our business model. So thank you everyone. Thank you very much.